All right, we are on the practice problems. They're not too bad today. The first section here is just stating we're on problems 1 through 8. It's just asking you to state if it's exponential growth or decay, and then give the rate. You remember it's 1 plus or minus r is equal to that number in the middle inside the parentheses. So we're going to set that up and solve for r. All right. So number one states y is equal to 3 times, let's see, y equals 3 times 1.61 to the power of t. This is going to be exponential growth. We look inside here and it's greater than 1. So I know that that's going to be growth. And my equation to solve r is 1 plus, because it's growth, r equals 1.61. We're going to subtract 1 on both sides and get r is equal to 0.61. We move our decimal place over twice and we get that it is 61%. You see how that works? Pretty simple, huh? Number 2 says y is equal to 9.5 times 0.098 to the power of t. That is definitely less than 1. So that is definitely decay. And then we're going to say 1 minus r. This is a little bit more time consuming, but 1 minus r equals 0.098. We subtract 1 on both sides, and then we get 0.098 minus 1 gives us negative r equals negative 0.902. We know that we're going to multiply this whole thing by negative 1 to get rid of the negative, and we get r equals 0.902. We move that decimal place over twice and we get 90.2%. If something is decaying by 90.2%, get away. All right, number 3. Number 3 says, f of x. Has anything changed when we write f of x? No. So f of x is equal to 5 times 2/3 to the power of t. We know that that's going to be decay because 2/3 is less than 1. So 1 minus r is equal to 2/3. Subtract 1 on both sides, and I get negative r is equal to negative 1/3. Multiply the whole thing by negative 1, and I get r is equal to 1/3. The decimal version of this is 0.3333 repeating. So we're going to move that decimal place over and say 33.33%. Okay, so there's our answer. And here's our answer so far. All right, number 4 says y is equal to 0.5 times 3/2 to the power of t. We're not worried about what's up front. We're worried about what's inside. That number is greater than 1, so it is growth. And we get 1 plus r is equal to 3/2. We subtract 1 on both sides, and we get r is equal to, trying to save space here, r is equal to 0.5 or 1/2. That is also equal to 0.5. So we move our decimal place over and we find that that is 50%. All right, number 5 is 21. G of x, still nothing changes. That's the same thing as y. So g of x is equal to 21 times 1.1 to the power of t. So we see that that's greater than 1, so we know it's growth. So that changes our equation to 1 plus r is equal to 1.1. We subtract 1 on both sides and see that r is equal to 0.1. We move our decimal place over twice and get 10%. Number 6, we have y is equal to negative 7 times 0.8 to the power of t. We see that that is less than 1, so we know it's decay. We use our decay equation, which is 1 minus r equals 0.8. Subtract 1 on both sides, and I get negative r is equal to negative 0.2. Multiply the whole thing by negative 1, and I get r is equal to 0.2. Move my decimal place over, and I know that that is 20%. Number 7, says h of x, still nothing has changed, is equal to negative 2/3 times 5/4. So this is a weird one. I want you to please type this in your calculator. I'm going to hit pause and I'm going to type it in and show you as well. So I type this into y equals negative 2/3 times 5/4 to the power of x on the calculator. Let's see. This is the old way of doing fractions. That's how I'm used to doing them because I'm old. If you want to type yours in a different way, that's fine. So let's hit graph and let's see what happens. It's a very, very, very slow. Is that growth or decay? Okay. So we look in here and we see that that is growth because it's greater than 1. But we look out here and we know that that's going to be flipped. So we know that a flipped growth is really decay. Okay? All right. So what do we use then? We're not worried about really is it growth or decay overall. We're only concerned with this number right here. So we're going to treat it like growth. It is decay, but we're going to treat it like growth. It's decay because of this little guy up front here. Right? But to find your rate, you're going to treat it as growth. So we're going to call this one decay because that's what's going on. It's decreasing over time, but we're going to use the 1 plus r to find our rate. Okay? So we do that. 5/4, we subtract 1 on both sides, and we get r is equal to 1/4 or 0.25, which is 25%. Okay. Number 8. Number 8 is y equals 4 times 1/2 to the power of t. This one's pretty basic. That is definitely less than 1, so we're talking about decay. And then we use our decay equation. Subtract 1 on both sides, and we get negative r is equal to negative 1/2. Multiply the whole thing by negative 1, and we get r is equal to 1/2, or r is equal to 0.5. Move our decimal place over twice, and we get 50%. All right. Number 9, it says the directions write an exponential function or decay function. Predict the function value for each situation. So we're going to write a function and answer the question. Number 9 says that an annual sales for a company are $149,000 and are increasing. So our original rate, y equals our original $149,000, and are increasing. So we know it's 1 plus, and the rate is 6%. So we turn that into decimal form, and that's 0.06 per year. Determine the equation for 7 years. So our equation is going to be this for our function, our equation, right? That works for all the years. And then we're going to plug in a 7 here. Y equals 149,000 times 1.06 to the power of 7. And we're going to find out what our answer is. So it says our annual sales will be 224040.91. Okay, so this is our annual sales right here after 7 years. Looks like that company is expanding, growing pretty rapidly. Number 10, it says population of a small town. Population of a small town is 1,600 and decreasing, 1 minus, at 0.03%, or 0.3%, sorry, 0.3%. So we're going to move that decimal place to the left 2 times to get 0.003. And that's over t years. So that's our equation, just like this one. That's the first answer. And that's the second answer. This is our first answer here. And then we're going to drop in y equals 1,600 times 1 minus 0.003 to the power of 10 years. So we're going to type that in our calculator and see that it is 1552. And it has a decimal, but we don't include those decimals. That's all trash information. So 1,552 people. That is our answer right there. Number 11 says, let's see here. Number 11 says, you start off with 700, so y equals 700. It's increasing, so 1 plus at a rate of 1.2%, so 0.012. And to the power of t, that is our equation. But after 8 years, it's going to be y is equal to 700 times 1.012 to the power of 8. We type that in our calculator to get 770.09. We always round down with money because the bank gets to keep that money, right? We're leaving money in the account, so they get the other stuff. Number 12 says the population of a country growing at a rate of growing, so we know that that's 1 plus. So originally it's 58, y equals 58, 1, 2, 3, 1, 2, 3. So that's 58 million growing 1 plus at a rate of 0.1%, so 0.001 to the power of t. That's going to be our equation, to the power of t. That's our equation, and then we're going to type that in our calculator to find the final answer after 3 years. We'll replace this one with 3. So y is equal to 58 million times 1 plus 0.001 to the power of 3. And we get 58,174,174, and we cut it off there because we're not having a pair of legs walk around the building. Okay. All right. Number 13, just 2 more left. 13, running out of paper room here. Number 13 says it has an investment of $8,200 loses value at a rate, so 1 minus of 2% a year, so 0.02 per year. That's going to be to the power of t or to the power of x. So there's your first equation. It's the original amount. It's decay, so 1 minus the rate in decimal form to the power of t or x. Okay, we write that, and we're looking for 7 years. How much will it be after 7 years? Well, if you're getting losses every year, I hope you take that investment out. So after 7 years, we'll have $7,118.62. They get to keep the rest of that money. 62 cents. Okay. All right. Please pull that investment out. And then finally, number 14, I'm going to use the last 2 lines on this thing. Number 14 says a new car worth $25,000. So y is equal to 25,000. Decreases. So 1 minus at a value of a rate of 15% annually. So 0.15 to the power of t. That's our first thing. Then we're going to say, how much is that worth after 6 years? So 1 minus 0.15 to the power of 6. Type that in our calculator. And we get $9,428.73. Could be 74 cents. Let's call it 74 cents. Since now it has a value. And it's in your favor a little bit. So $9,428.73 or 74 cents. All right. I hope you don't have any questions about this. I hope it's pretty simple for you. If you do, please type them in the comment section below. The Google Classroom question. I'm going to post the video and post the Google Classroom question in a moment. Have a great and wonderful day, and I will talk to you later.